Guys, the next step is we're going to name ternary ionic compounds. This sounds like a pretty weird word, but hang in there. It's not nearly as bad as what it sounds. So this is part of our nomenclature series, and it's number 4 in our video series. First of all, what does ternary mean? Ternary means composed of 3 parts. So a ternary ionic compound is one that's composed of 3 elements instead of 2 elements like we had in binary ionic compounds. So therefore, these polyatomic ions are part of a ternary ionic compound, meaning you're going to have more than 1, more than 2, and you could have 3 or even more elements as part of one compound. What are the polyatomic ions? Poly means many, and let me squeeze over here. So poly means many, and polyatomic ions are ions made of many elements. So if we look at some of these common polyatomic ions here, we have ammonium, for example. Ammonium has NH, and it has N and H in there. Hydroxide has O and H. Nitrate has N and O. So it doesn't really matter like how many they necessarily have, how many atoms of a particular type at this point. What does matter is that there's more than one type of element. And you have a list of the common polyatomic ions in the back of your periodic table that you can use for any assignment and any quiz and test. Now, to name the ternary ionic compounds, keep it simple. Don't make this harder than what it is. You're going to name the metal, and then you're going to name the polyatomic ion. It's truly that simple. The only time you won't do that is if you have a polyatomic cation, like you have here for ammonium, which is NH4+. This polyatomic cation is actually going to come at the beginning because we know that we write metals first or the cation first in a chemical formula. So here's some examples, and we have down here first NaNO3. So we name the metal, which is sodium, and then we look at the entirety of NO3. And if you look on the back of your table, you'll see that NO3 is nitrate. So you literally just write the word. Don't change it in any way. Just call it sodium nitrate. This next one, we have K is potassium. So we start with potassium. And then we look to see what is SO4, and that is sulfate. Now, I will tell you guys, those of you who are going on to AP Chemistry, it's a wise idea to start learning those common polyatomics now because you won't have that handy-dandy little sheet and that handy guide with you all the time. You're going to have to know a lot of those. But if you work with them enough, you'll know them anyway. Now what we have here is we actually have the polyatomic at the beginning, and we have just the anion at the end, and it's just a single anion. So we're going to name our polyatomic, which is ammonium. So we name it just what it is. We don't change it in any way. And then just like we would do in a binary compound, we're going to say it's chloride. So notice we use the IDE here, just like we would in a binary compound. Now you try. So pause your video for a second, and then you try, and I'll go over these. Okay, let's try here. We have KNO2. So we write out the word potassium and look up NO2 on your polyatomic chart, and you're going to find that it's nitrite, which is different than nitrate. Nitrate is NO3, nitrite is NO2. This next one, we have calcium. So calcium, and then what is PO4? Well, if we look up on our polyatomic chart, we're going to find that PO4 is phosphate. So we have calcium phosphate. And finally, we have 2 polyatomics together. So we're just going to name it like it is. This is the easiest one to name ever because you don't have to change it in any way. You have ammonium and you have nitrate, and you just put the 2 together, and you have ammonium nitrate. Now that's the part that's not so bad, and the next part's not terrible, but it's a little bit different, and that's writing the chemical formula from the ionic compounds. So you have a little bit different rules here. So you're going to write the symbol of the metal or the cation, Determine the charge on the metal. Hey, that sounds really familiar, a lot from binary ionic. Write out the symbols of the polyatomic ion. Determine the charge on the polyatomic. Crisscross applesauce, and be sure to reduce just like we have before. So let me show you some examples. Potassium phosphate, for example. We have potassium, which is K. We look on our periodic table to find K is a plus charge. Then we look at the back side of our periodic table for phosphate, which is PO4, and phosphate has a 3 minus charge. So we're going to crisscross all the way. And so since there's a 1, we don't need to carry over that 1. So we have K3PO4. The next one we have ammonium sulfate. And ammonium is a polyatomic. And that ammonium is NH4 and it has a plus charge for the whole thing. And sulfate is SO4 and it has a 2 minus charge for the whole thing. So if we crisscross the charges, the 2 is going to go here and the 1's going to go here. So we actually have to put NH4 in parentheses because we're going to put a 2 on the outside of it. And then we have SO4. That 2 came from the charge on SO4. And finally, we have magnesium nitrite. So Mg is a 2 plus according to our periodic table. Nitrite is NO2 and the whole thing has a -1 charge. So if we crisscross, we're going to bring that 2 down on the outside. So we'll have magnesium. We put our nitrite in parentheses, and then we're going to bring our 2 from the charge on magnesium to the outside of the nitrite. Now you try some on your own. Pause the video and try some and then come back and I'll help you. So this first one here, sodium carbonate. You have sodium is Na, and then you'll see carbonate. Oh, that's not just carbon. So I need to look that up. So you look it up on your periodic table on the back side with your polyatomic ions, and you're going to find that carbonate is CO3. And it's got a 2 minus charge, and sodium's got a +1 charge. So that 1 is not going to do anything, but that 2 is going to make us have Na2CO3 for sodium carbonate. Ammonium phosphate, we have NH4 and it has a plus charge. Phosphate is PO4 and it has a 3 minus charge. So I'm going to keep my polyatomics in parentheses as I change my charges. So now I have NH4 in parentheses and I have a 3 on the outside, and that 3 came from the charge on phosphate. And then I can write PO4. You can put that in parentheses. It's not going to hurt anything, but since you don't have another subscript on the outside, you don't have to worry about that. And finally, I have barium sulfate, Ba, and notice sulfite. So I'm going to look that up and I'm going to find sulfite is SO3 and it has a 2 minus charge and barium has a 2 plus charge. So those are actually going to cancel because if I would crisscross, I would get barium 2 and then I would have SO3 2 and I'd have my 2's on each side so I can reduce that to BaSO3 for barium sulfite. Now you guys work through some of the problems that I gave you.